Hello guys, welcome to my YouTube channel. My name is Quartey and I would like to talk about data path cycle. So one may ask, why does the data path cycle have a huge impact on the performance of the CPU? Data path cycle refers to the sequence of operations through which data flows in the CPU. It involves fetching, decoding, and executing instructions. A high-performing computer system is one that can perform tasks quickly and effectively, while minimizing the amount of time and resources required to complete these tasks. Here, we'll talk about factors that impact the performance of the CPU. Core functionality of the CPU. The CPU's primary job is to execute instructions, and the data path is the route that connects the components involved in this process: memory, registers, arithmetic unit. If this cycle is slow or inefficient, every operation in the CPU becomes slower. Now let's talk about instructions execution speed. Each instruction executed by the CPU requires a journey through the data path. This includes fetching the instructions from the memory, and decoding is the instructions in the control unit. You may ask, what is executing? Executing is the arithmetic logic unit or similar component. So, how do you store? Storing is the result in the registers. If the data path is optimized, these steps happen quickly. A poorly designed or slow data path means its instructions take longer, directly reducing the CPU's performance. Now, let's talk about bottlenecks in pipelining. What is bottlenecks in pipelining? Modern CPUs use pipeline to process multiple instructions simultaneously. For example, while one instruction is being executed, another can be fetched and the entire decoded. However, if the data path has bottleneck, which is a slow memory access or connection for resources, it causes the pipeline stalls, where the CPU have to wait for one stage to complete before moving forward. This significantly reduces the throughput of instructions. Now, what is instruction with cache and memory? The data path links the CPU with cache and memory. If the connection is slow or inefficient, accessing instructions and data becomes a bottleneck. For example, a slow memory access forces the CPU to wait, delaying execution. If the cache hierarchy L1, L2, L3 is not effectively utilized by the data path, performance suffers as the CPU has to rely on slower main memory more frequently. So, how does the CPU fetch, decode, and execute instruction? The CPU fetch, decode, and execute instructions through a process known as instruction cycle. This cycle consists of three main steps, which is the fetch, the program counter into bracket the CPU. This holds the address of the next instruction to be executed. The instruction is then fetched from the memory, which is the RAM, random access memory, and loaded into the instruction register, which is the IR. The CPU is incremented to point to their next instruction. Then we are talking about the decode. The CPU interprets the fetched instruction. The instruction in the IR is broken down into its OPS, operation code, and operand, data or memory address. The control unit determines the operation to perform and activate the necessary CPU component, which is the ALU and registers. Now, let's talk about execute. The CPU performs the operation specified by the instruction. If it's an arithmetic or logic operation, the ALU processes it. For data movement, the data is transferred between memory and registers. The result is then stored in appropriate register or memory location. Now, I think this is the end of our presentation. So, today we've learned about how the data path cycle have a huge impact on the performance of the CPU and how it executes, decodes, and fetches an instruction, which is done by the CPU. Bye guys. Please subscribe to my YouTube channel and come back for more instructions about computer architecture. Bye.